All right, today we're going to talk about inverse of a relation. So we have previously known what a relation is, an inverse is. An inverse can be thought of as an undoing. So most familiar, we do this in algebra. So the undoing of adding 4 is, subtracting 4. Those two operations cancel each other out. If we multiply by 4, we can choose one of two methods, right? We can divide by 4, which most people pick out right away, or we can multiply by a quarter. The undoing of the sign operation is, that's right, you've named it inverse sign. An inverse of a relation or a function can be thought of as an undoing. Recall from previous course that the inverse takes point xy and maps it into an image point yx. For every point xy on the relation, there is a point yx on the inverse. Now, what's really important is graphically, we start off with point xy and it maps it into the image point yx. As a consequence, our transformation will take the relation and reflect it about the identity line. The identity line is y is equal to x, so slope 1, y-intercept 0. So let us take some time. I'm going to hit pause here, and I would like you guys to, using the mapping notation, graph the inverse relation of the graph. So graph, right? Y is equal to f of x definitely is a function, but graph the inverse. There I have it. I took the 4 very obvious points on my function, and now I've graphed the inverse, or I've mapped out the inverse points. So point negative 2, 3 turns into point 3, negative 2. Perhaps I'm going to switch to red. 0, 0 transforms into 0, 0. 2, 1 maps into point 1, 2. 4, 1 will map into point 1, 4. And there you have it. So the red graph will in fact be the inverse of f of x. And what we can see is that the red graph is not a function, but the red graph is an inverse. So let's talk specifically about functions. Now, this is going to get wordy. It seems like I'm going to talk in circles, but I think it's pretty good. A function f will have an inverse, like this. However, the inverse may not be a function, again like this. If f has an inverse of a function, it is declared an inverse function. And then you can use the notation f inverse, or f to the power of negative 1. So let us consider the function f of x is equal to x squared. Without question, this parabola is a function. And we can test if it's a function, and basically it is a function because each x maps into exactly one y. For every x, there's only one y. However, the inverse of f is not a function. Therefore, we have to restrict the domain of f to ensure that the inverse of f is a function. So often we're after functions. So in this case, the inverse will not be a function. So let's press pause. I will get you to graph that. Let's do this, team. 1, 2, 3, pause. Let's graph. 1, 2, 3. There we have it. So I graphed my inverse relation. So I took points that were very important to the original parabola, and I simply used the notation, or the mapping notation, xy moves into point y comma x. So we had an upward opening parabola, which is a function, and it moved into a sideways opening parabola that was red, so it's not a function. So a function has an inverse function if each element of the range maps into exactly one element of the domain, or into one x. So a function will have an inverse if it passes a horizontal line test. So if each element of the range maps into one element of the x, the function is said to be a one-to-one function. So considering here y is equal to 4, what we see along this line, this would be a horizontal line. Well, what's wrong with this? Well, for a given y value, a specific y value, like y is equal to 4, we have two possible x values. So it cannot be one-to-one and will not have a vertical line test. And if you think about it, a horizontal line test reflected about the identity line will become a vertical line test. If a function f is one-to-one, then the inverse of f will also be a function f inverse. To put it simply, or not simply, the function f will have an inverse function if and only if it is one-to-one. Really important. It must pass the vertical and horizontal line test.